वन ऑफ द मोस्ट इंपॉर्टेंट कंसेप्ट जिसके आने की प्रोबेबिलिटी सबसे ज्यादा है, इट इज रेक्टिफायर. इट इज अ डिवाइस which is used to convert alternating current to direct current. सबसे पहली चीज तो ये ऑल्टरनेटिंग करंट को डायरेक्ट करंट में कन्वर्ट करने का काम करता है रेक्टिफायर. प्रिंसिपल when PN junction is forward bias, it offer low resistance, and when reverse bias offer high resistance. So, in forward bias, it will be in on state. In reverse bias, it will be in off state. This is the principle how we convert AC to DC. Device which convert AC to DC. When forward bias PN junction, it offer low resistance. When reverse bias PN junction, it offer high resistance. जब फॉरवर्ड बायस में होगा करंट फ्लो होगा, जब रिवर्स बायस में होगा करंट फ्लो नहीं होगा. Types of rectifier. First, we have half wave rectifier. Second, we have full wave rectifier. Such as if this is input, when it is half wave, only half of the wave gets rectified. When it is full wave, output with full wave rectifier. So two types of rectifiers are there. Half wave rectifier is also there and full wave rectifier is also there. The next one is circuit diagram. Circuit for half wave rectifier. We will take AC as input. Like this. This will be input and this will be output. Only one PN junction is there. If we want to draw circuit for full wave, see the difference in the circuit. Input, we need to construct two diodes there. It is called center tapping, and you will usually take output here only. So here we will take output. So two PN junctions are there in this. Half wave rectifier, full wave rectifier. Only one PN junction. Two PN junction. No center tapping is required. यहां से जब कनेक्ट करते हैं इट इज कॉल्ड सेंटर टैपिंग. Center tapping is required. Next one is working of half wave rectifier. This input fed to this transformer based on the concept of mutual induction. So if you want to lower potential, you can lower potential. If you want to increase, you can increase. Only one of the diode having resistance due to this AC. If I take this as A and this as B, in half of the cycle A will be positively charged, B will be negatively charged. Then when A is negative, B becomes positive, then A again becomes positive, B becomes negative. So we will write it like this. When we get AC input, A in half of the cycle has positive polarity and in other half negative polarity. When is connected to P type, we have forward bias. P is connected to positive, so it should be forward bias. Offer low resistance and signal will pass through PN junction. जब भी ये टर्मिनल पॉजिटिव से कनेक्ट होगा, सिग्नल इसमें से होकर पास हो जाएगा. बट अगर हमारे पास में ऐसा हुआ, when negative is connected, reverse biasing will happen, high resistance, so signal will not pass. 3 पॉइंट पे आप इस एजेंडा को क्लियर कर सकते हैं. फर्स्ट, AC input is providing positive negative pulses. When P is connected to positive forward bias, when P is connected to negative reverse bias. When it is forward bias, current will flow. When it is reverse bias, current will not flow. So as a result, what will happen? Waveform of input and output this will be your input and this will be output. When input positive, signal will pass. Negative, it will not pass. Positive, again pass. Negative, not pass. Again pass, not pass. This is how you will get the output. Whenever it is positive, signal will pass. When it is negative, signal will not pass. Positive, it will pass. Negative, not pass. Positive, it will pass. So in half of the wave, we get the rectification. In other half, this part has already rectified. Rectified means eliminated. So this is how you will get a waveform of half wave rectifier. So to get the full wave rectification, we need a minimum of 2 diodes. And here we have the next concept called full wave rectifier. As we know, we have 2 diodes there. This input is supported with transformer again. Having 2 diodes at the same moment. This diode is D1, this diode is D2. We know that when this terminal is positive, this terminal is negative. This terminal is negative, this terminal is positive, and so on. Input applied to this point A is the same. So in its working, when input applied to A is positive, B will be negative. जब भी इस पे पॉजिटिव होगा इस पे नेगेटिव होगा. So that D1 is forward bias and D2 reverse bias. At a time एक डायोड फॉरवर्ड बायस हो गया, एक टाइम रिवर्स बायस हो गया. And we can see that signal will pass through it like this. So the current through D1. Second, when input to A is negative, B will be positive. अगर एक नेगेटिव होगा दूसरा पॉजिटिव हो जाएगा. D1 रिवर्स बायस्ड, बट D2 फॉरवर्ड बायस्ड. और क्योंकि इस बार D2 फॉरवर्ड बायस है, so current will flow this time to D2. So in the second half, the current will flow through D2. Hence, in half of cycle, D1 will allow current, and in other half, D2 will allow current. एक बार D1 से करंट फ्लो हो जाएगा, दूसरी बार D2 से करंट फ्लो हो जाएगा. इन आउटपुट, आप इस आउटपुट को देखिएगा, अगर मैं इन दोनों टर्मिनल्स के बीच में देखूं, करंट हमेशा एक ही डायरेक्शन में फ्लो हो रही है. सो करंट विल फ्लो ओनली इन वन डायरेक्शन, X to Y. हमेशा एक ही डायरेक्शन में फ्लो हो रही. वही हमें चाहिए था, हमें एक ही डायरेक्शन में करंट चाहिए थी. We got it with help of this. So we have the two diodes. The first diode when conduct, D2 will not conduct. When D1 will not conduct, D2 will conduct, and the process will continue. So you will get the complete full wave. So the wave formation looks like this. Input, D1, more diagrams and graph you will draw, more marks you will get in your exams. D2, output. सब एक ही तरफ. This is how you will get the full wave rectification. But this is fluctuating input, you can clearly see. इस fluctuating input को हम output में या direct circuit के अंदर नहीं ले सकते हैं. So what finally we will do, we have another circuit called filter circuit. Filter circuits simply eliminate all the fluctuations. So output from rectifier प्लस फिल्टर, ये आउटपुट आया रेक्टिफायर का। अगर मैंने इसको फिल्टर सर्किट में से निकाल दिया तो फिल्टर सर्किट इस पूरे को फ्लक्चुएशंस के गायब कर देता है, एंड फाइनली व्हाट यू विल गेट इज द कांस्टेंट डीसी। Throughout this, on y-axis you are taking current or potential, on x-axis you are taking time. So it goes like this. Can we use directly from the rectifier? You will say no, it is the fluctuating one, so it will not count. You will have to feed it into filter. Once it will be there in the filter, it will simply smooth this. ये सारे eliminate करेगा जितने variations आ रहे हैं उनको, and you will get the constant DC. This is how the rectifier will work in this manner, that your PN junction, one PN junction is capable of doing half wave rectification, whereas the two PN junction will be able to rectify your both the things, your input as well as output, so we will get the full wave rectification, and this full wave rectified output will be fed to the filter, so you will get the constant output in this manner. So whenever we have this kind of circuits, ध्यान से देखिएगा, you have here a supply. Say we have a DC supply. One PN junction is here with a bulb. Another PN junction is here with another bulb. This is bulb B1. This is bulb B2. And if somebody will ask you that which of the bulb will glow, you can clearly see D1 and D2. So the answer is, as D1 is forward biased, so B1 will glow. But D2 is reverse biased, so B2 will not glow. This is one type of conceptual problems usually asked. The same thing may happen whenever you will take ideal diode or PN junction. Ideal diode in forward bias, resistance is 0, and when it is in reverse bias, then resistance becomes infinity. So when it is ideal diode, generally हम इन circuits के अंदर ideal diode use करते हैं. So ideal diode means forward bias, no resistance will be there. Reverse bias, signal flow होगा ही नहीं किसी भी हालत के अंदर. अब जैसे ये वाला क्वेश्चन दे दिया आपको, this diode, another this diode, and this battery having this emitter here. This battery is 10 volt, this is 10 ohm, this is 10 ohm, and diode D1 and D2, and they are asking what will be the reading of the emitter. Clearly, as you know, that this diode is forward bias, but this diode is reverse bias. So current will flow only through this, and that's why current should be equals to 10 by 10, so it should be 1 ampere. लेकिन अगर मैं दोनों डायोड को ऐसे कर देता तो these two will be in पैरेलल होते ही 5 हो जाता और करंट की वैल्यू हमारे पास में 2 हो जाती. सो एक इस तरह के प्रॉब्लम्स इसके ऊपर हो सकते हैं जहां पर आपको डायोड की पोजीशंस और उसके बाद में पूछा जाए कि करंट क्या फ्लो होगा या एमिटर की क्या रीडिंग होगी. दैट इज अनदर वे टू आस्क द क्वेश्चंस ऑन योर पीएन जंक्शन थिंग्स. डायोड इन फॉरवर्ड एंड डायोड इन रिवर्स बायस.